Next, coming to chemical properties of alkyl halides. So mostly alkyl halides undergoes nucleophilic substitution reactions. Okay, they more readily undergoes nucleophilic substitution reactions, and also some elimination reactions and some other reactions. First, coming to nucleophilic substitution reactions. So here, first reaction with the boiling aqueous potassium hydroxide. So here halogen atom present in the alkyl halide, that is substituted with the OH minus ion, which is nucleophile here. Okay, and we get alcohol as product. And instead of potassium hydroxide, if you use silver hydroxide. Okay, silver hydroxide, which is formed like this. Silver oxide with water forms silver hydroxide, and silver hydroxide that gets reacts with alkyl halide. Halogen atom gets substituted with the OH group. Here also we get alcohol. Okay, so both the potassium hydroxide, which is boiling aqueous potassium hydroxide, and silver hydroxide, we get alcohols. Next reaction with the potassium cyanide. Okay, alcoholic potassium cyanide. So here halogen atom gets substituted with the cyanide, Cl, and we get alkyl cyanide. If same reaction is carried with the silver cyanide, instead of alkyl cyanide, we get alkyl isocyanide. Okay, so with the silver cyanide we get alkyl isocyanide, cyanide. Okay, and here we get NC. NC indicates here isocyanide. Okay, so that is with the potassium cyanide. Then with the potassium nitrite, K go to potassium nitrite. So alkyl halide when reacts with potassium nitrite, halogen gets substituted with the nitro group. Okay, so here there is a possibility for the formation of alkyl nitrites. Okay, so with the potassium nitrite we get alkyl nitrite. So in this, carbon which is present in alkyl group, that is linked with the oxygen. Why? Because nitro group is bidentate ligand. Okay, so it contains two donor atoms, nitrogen and also oxygen. Okay, so here linkage is in between oxygen and carbon, which is present in alkyl groups. So this is alkyl nitrite. And the same reaction is carried with silver nitrite. Silver nitrate we get nitroalkane. So here linkage is present in between carbon of alkyl group and nitrogen of nitro group. Okay, and formed compound, that is nitroalkane. Okay, then coming to with sodium alkoxide. This is very important reaction. So with the sodium alkoxide, okay, so sodium alkoxide, NaOR. If it is C2H5 group, we can call it as sodium ethoxide. Okay, so sodium alkoxide reacts with the alkyl halide. Okay, and this reaction is a named reaction which is called Williamson synthesis. This is very important reaction which is used for the preparation of ether. Okay, so here alkyl halide reacts with sodium alkoxide, and here halogen group that is substituted with alkoxide group. Okay, and we get ether here. Ether. For example, if it is alkyl group is C2H5 ethyl. So ethyl chloride, okay, with the sodium ethoxide. Sodium ethoxide. Okay, we get diethyl ether along with the sodium chloride. So this is diethyl ether. So this is Williamson synthesis, which is used for the preparation of ethers. Next, one more reaction for the preparation of ether from alkyl halide, that is with the dry silver oxide. So 2 moles of alkyl halide reacts with the dry silver oxide. Here also we get ether. Okay. Then with ammonia, this is also called as Hoffman ammonolysis reaction. So in the substitution reaction with ammonia, we get amines. First we get primary amine, and further it converts into secondary amine. Secondary amine finally into tertiary amine. Okay. So different amines are produced when alkyl halide reacts with ammonia in stepwise reaction, and this is called Hoffman ammonolysis reaction. For example, alkyl halide first with ammonia, we get primary amine or NH2. Primary amine again with 1 mole of alkyl halide forms secondary amine. Secondary amine again with 1 mole of alkyl halide forms tertiary amine. Okay, so this is called Hoffman ammonolysis reaction. So all these are nucleophilic substitution reactions. Then coming to elimination reaction. Okay, so substitution, one atom gets substituted with another atom. So atom or a group of a compound gets substituted with atom or group of another compound. So that is substitution reaction. So elimination reaction. Elimination reaction means removal of atoms from a compound. Okay. So here elimination of halogen and hydrogen. Okay. Hydrogen and halogen both gets eliminated when alkyl halide reacts with alcoholic potassium hydroxide. This is very important. Okay. This is also called as dehydrohalogenation reaction. Okay. Elimination reaction is also called as dehydrohalogenation reaction. So why so called? Because one hydrogen and one halogen gets eliminated from the alkyl halide, and alcoholic potassium hydroxide is called dehydrohalogenating agent. Okay, reaction takes place with the alcoholic potassium hydroxide. So it eliminates both hydrogen and halogen. So with the elimination we get alkene, unsaturated compound. So elimination reactions, in elimination reactions saturated compound converts into unsaturated compound. Okay. So dehydrohalogenation takes place with the alcoholic potassium hydroxide and we get alkene. Okay. Then according to Sedgefroll, we get a mixture of alkenes. Okay. So with the higher alkyl halides. Okay. So if we use aqueous potassium hydroxide, it undergoes substitution. Instead of elimination, it undergoes substitution. That is very important for objective. Elimination reaction takes place with alcoholic potassium hydroxide, whereas substitution reaction takes place with aqueous potassium hydroxide. Okay. Next, Sedgefroll.